everyone. So in this video we are going to discuss the BMath 2008 problem number 4. So the problem says that you have a1 a2 till an integers. So basically you have n integers and show that there exists integers k and r such that the sum ak plus 1 till ak plus r is divisible by n. So first of all, you would be getting that this is a number theory problem, but the main thing is that it's a combinatorics problem and it involves PHP. So the main thing about this problem is that you have to show that there exists integers k and r. So without worrying about integers k and r, so what actually we have to show is that there is a consecutive sum which is divisible by n. Okay, so this is a very nice property of the integers, that is, given any set of n integers, you have a consecutive sum which is divisible by n. So how do we go about this? So we are given a1 a2 ... till an. Okay, now since we have to show that a consecutive sum is divisible by n, so let's first divide any of these numbers by n. So if one of them is divisible by n, then we would be done, because if you look at the problem, so the sum is going from ak to a k plus r. So now basically then you have to show that there exists integers k and r. So then if suppose for example a2 is divisible by n, then k would be 2 and r would be 0, as simple as that. So they haven't told you that positive integer k and r, so there exists integers k and r. Okay, so the first thing is that if any one of them is divisible by n, then you are done. Or else what we would do is we would take the consecutive sums like the partial sums. So first a1, so if none of them is divisible by n, then a1 is congruent to, suppose, r1 modulo n, and then a2 would be congruent to I'll take the sum a1 plus a2 is congruent to r2 modulo n, and so on and so forth till a1 plus a2 plus ... till an. So I'm summing the whole thing, and that is congruent to. So how many sums have am I encountering here? So a1, then a1 plus a2 till a1 plus a2 till an. So n sums are there. So rn modulo n. Now if one of them is divisible by n, or if one of these remainders is 0, then we are done, because these are all consecutive sums. Okay, so if not, that is, if none of the ri's is equal to 0, then what we know is, that is, we have r remainders. Now notice that when you are dividing by n, so n where n is a natural number, so you basically get n remainders, so 0 1 2 3 till n minus 1. So here none of the remainder is 0, so that means for the remainders, like if one of the remainder is 0, then I am done. Okay, so now the case, that is, none of them are 0. So then I have n remainders, and for each of them, how many choices do I have? N minus 1. Okay, because 0 can't be now a remainder. So that means I can say that since I have n remainders and I have n minus 1 choices. Okay, so think of this like the pigeonhole principle. That is, you have n minus 1 boxes and you have n pigeons. So here the boxes are referring to the remainders, okay, the possible remainders 1, 2, 3 till n minus 1. And so here 1, 2, 3 dot 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 till n minus 1. So suppose these are the boxes, okay, and now what do you do? So you bring the pigeons. So where are the pigeons? These are the pigeons, that is R1, R2 till Rn. Okay, and now you have n pigeons, and you know that none of these Ri's are 0, so that's why we haven't included the box 0. So now these okay, so let's first bring R1. So it must be one of these 1, 2, 3 till n minus 1. I'll put it in the corresponding box, okay, and so on and so forth. I'll be putting each of them in the corresponding box. And now by PHP I can say that, by pigeonhole principle we can say that because I am putting n remainders in n minus 1 boxes, so one box will receive at least 2 remainders. So by PHP at least two remainders will be the same. Okay, so at least 2. So now let suppose Ri and Rj be the same remainders. Okay, so that means what I am saying is that Ri is congruent to Rj modulo n. And now what? So let's bring Ri. So Ri would be summation of a1 a2 till ai, and without loss of generality, let's take that one of I is greater than j. Okay, so because I am having two different remainders, so I and j would be distinct, and so without loss of generality I can take that I is greater than j. And then what? Then this Ri, which is a1 plus a2 plus dot 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 aj plus a j plus 1 plus dot 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 till a I, because I is greater, and this thing is congruent to what do we have? Rj, which is a1 plus a2 plus dot 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 till a j, and this whole thing modulo n. Okay, so I have these two sums and they are congruent under modulo n. Now what happens? I can take this on the other side, and these a1s and a2s till aj would all cancel out, and I would be getting a j plus 1 plus dot 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 till ai is congruent to 0 modulo n. Okay, and so what you have to now show that there exists. So we have basically found out a consecutive sum. Okay, now we have to show that there exists k and r such that this sum ak plus 1 till ak plus r is divisible by n. And so if you take this j plus 1 as k, so ak and then plus j plus 2 would be ak plus 1, and till where do we have to reach? We have to reach till ak plus r. So dot till a k plus r. Okay, so now that means what I am taking k as j plus 1, k as j plus 1, and I am here taking k plus r as I. Okay, and now from here you just find out r, because r is I minus k, which is k is j plus 1, so I minus j minus 1. So this is r, and this is j, this is k, and so we have found out r and k such that this sum ak plus 1 till ak plus r is divisible by n. So I think we are done with the problem. Yeah, so that's it for today. So see you in the next video. Thank you for watching.